In this video, the calculation of break-even quantity for several conditions will be discussed. We'll start with the basic break-even quantity. This is the quantity of product or service that is sold when revenues are equal to total cost. If revenues equal total cost, profits will be zero. For quantities greater than this break-even point, profits will be positive. For quantities less than this break-even point, losses will be incurred. This is important management information. We start this with the basic break profit equation. Net profit equals revenue minus total cost. Total costs are equal to fixed cost plus variable cost. And we can put that into symbols. Revenue is quantity times price. P is for price, Q is for quantity, minus the fixed cost plus the quantity times the variable cost per unit. We can clear these parentheses by multiplying through by a -1, get a minus fixed cost minus the variable cost. And here we move the fixed cost to the other side of the equation by adding fixed costs to both sides. So it is eliminated here, is over there. We're looking for the quantity Q, so let's get the Q on the other side. So we switch these two. We factor out a Q, start with. And you have Q times P minus VC, and move that to this side, and you have Q times P minus VC equals fixed cost. And then we can divide by this price minus variable cost, P minus VC, and you get Q is equal to fixed cost divided by the price minus the variable cost. It's all in the content. If you didn't follow all of that, you can take it more slowly. The price, the unit price per unit minus the cost per unit, variable cost per unit, is labeled the contribution. It's the contribution that each unit of sale contributes to covering the fixed costs of the organization. Let's look at an example. In this case, our price was $5 and the variable cost is $3, so the contribution is $2. Each unit that's sold will contribute $2 to covering the fixed cost of 100. So fixed cost of 100 divided by 2 is 50 units. Or put in this equation, B10 is the fixed cost right here. B12 is the price. B11 is the variable cost. And you end up with 50 units. It's informative to look at this graphically. So let's bring up a graph here. Take out one more row to get it all on the screen at the same time. Almost all there. Let's get this down one more. So we're going to look at quantities that vary from 0 up to 100. And that's always a guess which ones to use, but you can change them easily in a spreadsheet, the beauty of spreadsheets. The fixed cost stays the same, so we won't have a column for fixed costs. Variable cost, the total variable cost is in capital letters, so it's a total for all units. We multiply the quantity, which is in this column, here it's 0, and B15, as it says here, times B11, which is the variable cost. And that's 0 for 0 quantity, 0 variable cost. The total cost is 100, which is your fixed cost plus the variable cost. Variable cost is 0, so the total cost is only the fixed cost of 100. If you don't sell any, the revenue is 0. So the profit at quantity of 0 is 110, or 0 minus 100 is minus 100. And that continues on. If we go up to, say, 20, the variable cost is 20 times 3 is 60. The total cost is at 60 plus the 100, or 160. The revenue is 20 units times 5, it's $100, and the profit is a negative $60. If you look down here for 50, you'll see that the profit is 0. This is then the break-even point. And we can graph that. The red line is the cost, total cost. both variable plus fixed, and it goes up at the rate that the variable cost goes up. The green is the revenue. Next starts at 0 and goes up. And you'll see they cross right at 50 units. So we can plot the profit as well in the blue, and it's negative here, and it becomes 0 at 50, the same point. So the break-even quantity for a price of $5 is 50 units. We have to sell 50 units to break even, cover a cost. If we sell more than 50, we will start making money. Next, we'll look at the case where you want to find the quantity to earn a particular amount of profit, a profit level. So the example of a break-even quantity to obtain a profit level. So instead of having 0 here on the left-hand side of the equation, we have a profit amount. The revenue minus costs will eat some profit. And we can go through basically the same derivation, except we have profit. We get to this step, we move fixed costs over as profit plus fixed cost. And then going through the same gyrations, Q is equal to profit plus fixed cost divided by the contribution, the price minus the variable cost. So we can state it this way. So if the same fixed cost 100, the same variable cost and price of $3 and $5, but say we wanted a profit of $120. This could be 120,000, 120 million. We'll keep it small and simple with $120. So we can solve for that with using this equation. Here we have it up here. B47 is the profit plus the fixed cost of 100. So that'd be 220 divided by the contribution, or the price minus the variable cost, B46 minus B45. You do that calculation, you get $110. Graphically, that looks like this. I started at 50, a little bit higher because we know the break-even point was higher than that without the profit. So with the profit, it has to be higher. So we'll start with 50. The variable cost, $3 times 50 is $150. If we add the fixed costs, 100, plus the variable cost, 150, plus the profit of 120, you have $370. The revenue for 50 units at 5 is $250. So if we plot that, here's the fixed cost plus variable cost plus profit that we have to cover with our contribution. Here's the revenue, keeps going up, and one point they are equal, and that comes out at about 110, which is what we calculated here. The graph takes at 0, points it to 0 and 110. The profit, which is revenue minus fixed cost plus variable cost, is 0 at 50, goes up to 10, and at 110 becomes $120, which is the profit that we wanted to achieve. $120 is about here, and that's about where this intersects. If you wanted to draw a line there, insert, shapes, a line, and we can draw a line from here over to there, which is about $120. And that then is the break-even quantity to attain a particular profit level. Another example of the break-even analysis is where you want to determine a break-even price. That is, what should a price be for a product so that you break even, your profits are 0, or greater, higher price will generate higher profits, and a lower price will give you losses. We start with the same equation we had, the profit equals 0, and go through essentially the same derivation, except that we're now going to solve for price instead of for quantity. So we get down to this stage here. We got quantity times price equals fixed cost plus quantity times variable costs. Well, the break-even price, P, is only on this side, so we divide by Q. Get the fixed cost plus Q times BC, which is the variable cost, and divide that sum by the quantity Q. And so that can be looked at two ways. It's fixed cost plus variable cost, the total variable cost, since it's in cap letters, divided by Q, or it's the fixed cost divided by the quantity divided by the unit variable cost. So either one of those equations work. So let's do an example. If we have fixed costs of $100, variable cost is $3, and the quantity is, say, 80, the total variable cost is $3 times 80, $240. So we can do this by B73, the fixed cost divided by the quantity, B75, which is, click on here and then they'll light up, it's 80, plus the B74, which is the variable cost, that's the second equation here, and the result is $4.25. Now we could do that similarly by using this other equation. The fixed cost is 100, the variable cost is 240, the total is 340. 340 divided by 80 gives you again $4.25. If we want to graph this, here's the prices that go from $3 to $5, and the total cost is again the sum of these two, 240 plus the 100, would be 340 to start with, and keeps going up. Revenue is the quantity times price. We said price $3 up to $5, so we get these revenues. The profit is the difference. We lose money up to $4.25, which is just what we had here. To graph that, you see that the profit crosses zero at $4.25, and that also is where the revenue equals the cost. The revenue in total cost in red, the revenue in green. And that's the break-even price. The final example we'll show will be where to find a break-even price that will achieve a particular profit. So the profit in the equation, instead of being zero, will be some profit number, and we solve these equations like we did above, and we did down the quantity times price equals profit plus fixed cost plus variable cost, total variable cost, Q times VC. And you divide by Q, you get P, and you get this equation here. Profit plus fixed cost divided by Q plus VC. So the fixed cost is 100, variable cost is $3, same as before, quantity of 80, but we want a profit of $40. That's what has changed, and we add the $40 to the fixed cost this time. It's really about the only difference. And you can graph that, and it comes out to be 4.75. We do this, B105 is a profit, plus B101 is a fixed cost. That's summed together and divided by the quantity, which is in B103. And then we add to it B102, the variable cost. And that is another example of break-even analysis. That includes these examples. Thank you.